Hi, my name is Bill Manning, and I'm here today to further discuss serial correlation within problem set 7. So before we can analyze and further discuss the data, we must figure out what we are trying to predict and forecast. So with that, our main research question is, how is Costco's yearly stock price significant in explaining Walmart's yearly stock price? And here you can see is our descriptive statistics table after using the outreg function copied from the output Word document. So technically, the only variables that do hold significance in our equation is Costco and Walmart, but Stata obviously does not know that. So it generates these other variables of year, date, and trend. But for our study, we're solely analyzing the variables of Costco and Walmart. So we can see that we have a total of 29 observations in the mean, which is the average. We can see that Costco has a higher average at 34.31, whereas Walmart has an average of 30.41. So moving over to the standard deviations, we know that the standard deviation is a measure of the amount of variation or dispersion of a set of values. So low standard deviation indicates that the values tend to be closer to the mean of the set, while a high standard deviation indicates that the values are kind of spread out over a wider range. So we can see that Costco has a much higher standard deviation in comparison to Walmart, which means Costco's values are spread out over a much wider range and not as close to the mean. And lastly, the min and max just show the minimum and maximum values for the given variables. And we can see that Costco has the highest max at 122, and Walmart has the lowest min at 1.98. Moving on, we know that we are trying to determine Walmart's yearly stock price. So therefore, Walmart is our Y variable, and we wanted to include Costco as the X variable because we saw it as important and valuable in explaining Walmart's yearly stock price. So with that, we ran both a static and dynamic model, and the dynamic model showed that, in fact, by adding just one more lag for Walmart, we could help further explain Walmart's yearly stock price and predict that, which is what we are trying to explain. So on this slide, you can see that the parallelogram results from our dynamic model. And here we can see that we only need to add one more lag because the PAC is greater than 0.5 at the first lag, but at the second lag, it is less than 0.5. So therefore, we do not need it, just one lag. So that one additional lag in Walmart's yearly stock price for the previous time period, that is just saying that is looking at Walmart's stock prices from the previous time period. So with that, we just add one more lag to the equation. And on this side, we can see the output of the time series regression, and we have GR Walmart L1 and GR Costco. And the coefficient for Walmart with the one lag is 0.543 with 3 asterisks next to it. And this means that the coefficient is significant at a 0.01 significance level, which is really good. We want that. We can directly interpret these results as well by saying that a 1 unit increase in Walmart's previous yearly stock price is associated with the 0.543 unit increase in Walmart's stock price for this year on average, holding all else constant. So moving kind of on over, the coefficient for Costco is 0.514. It also has 3 asterisks. Therefore, we can infer that both coefficients in the model are significant at the 0.01 significance level. And lastly, we can directly interpret these results by saying that a 1 unit increase in Costco's yearly stock price is associated with the 0.514 unit increase in Walmart's stock price for this year, on average, holding all else constant. Then lastly, in regards to issues we had to test for, we use the Durbin alternative and Bruce Godfrey LM to test for serial correlation. And we would reject the null and accept the alternative if the p-value is less than 0.05 or 5%. That would mean that we do have serial correlation with the model. Or we would fail to reject the null if the p-value is greater than 0.05, meaning serial correlation is not present within the model. And as we can see by the two models, both p-values are greater than 0.05. Ultimately and luckily, we can conclude that the dynamic model is a good fit model, and we fail to reject the null, and there is no serial correlation within the model. And that concludes my presentation. Thank you.